and then we're going to go to the new stuff really quickly. So I want to get this somewhat well graphed. So what do we know for sure again? Goes through 0, 1. Okay, I believe that's 0, 1 right there. What about when we're plugging in negatives? Can you explain why a negative gets it closer to 0?
Because it's in the denominator.
Yeah, okay, so this is flipping it up. So it's becoming this really giant fraction or small fraction, depending on how you want to talk about it. So then, like, it's coming like this, and it goes up, and then after that point, what happens? Okay, it increases a lot because it's exponential. And so, well, I guess I could kind of get that a little bit closer. Let's go, right, because it would be 2 to the first would be there. So then we go through that point, right? All right, so this one goes through that point like that. Okay, so then what we're talking about today are logarithms. And do we remember anything about logarithms graphically anyway? So let me get this up here. So it would be like, we've seen these things before? You've seen a logarithm before? So if I told you that a logarithm and exponentials are inverses, what would that tell you about the graph of these two things?
Be reflected over the line.
Yeah, what line is it?
Isn't it y equals x?
Y equals x. Okay, so it would be reflected over this line here. What happened there? My big old. Get that thing in the way. All right, so then inverse is like just the basic definition of an inverse is what? Something to do with the x's and the y's. Yeah, the x's and the y's flip-flop. Okay, so then like let's look at a couple different points. Namely, the first one here is 0, 1. So then if it's 0, 1 on the exponential, then what is it on the logarithmic? 1, 0. There. Okay, and so then when we pick a really, so I'm going to make up a value over here. Let's say that when it's 2 to the 1/4, right? If x is 1/4, no, that's not how I want to do it. Sorry. So if we did a -4, let's say, or let's make it easy, -3. So if we were doing 2 to the -3, what would that be? 1/8. Okay, and so then at -3, we'd get a 1/8. So if we do the inverse of that, it'd be what? An eighth and, like, so it's a coordinate. What was the other value? Yeah, okay, so an eighth and -3, so we'd be down like this. I want that in blue. Okay, and so then if we went in the other direction, like, I have this point up here, right, which is when x is 2, y is 4. So then that would mean 4, 2. Okay, and so then now it would look, oops, I missed it, but it looked like that, right? Okay, so we have some different things going on now. So let's talk about domain and range with our original exponential one. What is the domain of 2 to the x? Say it again. All reals. Yeah, we're allowed to plug in any value we want there. What about, let me get rid of this. What about the range of that? Okay, so is that okay with everyone? So we'll say y is greater than or equal to 0. Okay, so then what do you notice about the domain of the logarithm? Yeah, so we have this limited domain now. Okay, so then x is greater than or equal to 0, but the range now is all reals. Okay, and so what I said at the very beginning, how we're going to want to get up into exponents to find variables, solve for variables, we're going to use logarithms to do that because they're inverses of each other. And there's a couple more of these. So like if you look at page, no, where is that there? 313. On page 313, they go through a little bit more things, and we've mostly talked about these, right? But, right, they says logarithm has domain 0 to infinity. The range is all reals. Intercept now is at 1, 0. It's increasing. What does that mean? I didn't do this earlier today, but, you know, I'm going through this checklist, and it says it's increasing. So what does that mean? Say it again. Yeah, well, I like the way you said it first time. Say it again.
As like the x increases, it's like getting bigger.
What's getting bigger? No, you're almost perfect. You almost said it really well. So as x gets bigger, what's y doing? Okay, so that means it's increasing, right? So as x increases, y increases. Okay, so like no matter what you look at, because what ends up being, these things are climbing so quickly, or in the case of the logarithm, and you know they're going out to the right so fast, it looks like they almost become horizontal lines, but they don't. Okay, so they're always increasing. And then they got the y-axis of vertical asymptote. We kind of talked about that. Continuous is going to be important to you in the future. Okay, so how's that with the graph? All right, so just like with the exponential stuff, you want to be able to kind of have an idea of what's going on with this. And so all of this is true, but what if we wanted to move this around? What would we end up doing?
You can add like it'd be like 3 log 2 times x, like that would change.
Okay, so if we multiplied it by 3, right, it would grow a little quicker. Okay, what if we added 3? Would that change anything? It would move it up. Okay, so all these rules are still the same. And again, the better you are at understanding what the shapes are, the easier like calc will be. Okay, so keep an eye on that. Go back. There's really one move in this whole thing, and it's the one you really got to know. And so log base b, okay, that's how you read it. Log base b of some number equals an exponent. Okay, and so again, that's how it's read. Log base b of a number n equals p. And as long as you remember that logarithms are basically exponents, it's pretty easy to go to this statement. And this is the whole thing. So the base is still the base, the power, and the number. Right? These are interchangeable. And so basically, if you got a logarithm in a certain form, and this is logarithmic form. And this one is called exponential form. And so it just depends on what the problem is asking you, which is the better form to be in. And this totally could be something that shows up on the ACT, and that should make you super, super happy because it's really, really easy. Okay? A couple other note-taking things before we work on some problems is that if you have, and you guys should know some of this stuff, so like if we have that, there's no base there. So whenever there's no base, it's a what?
10.
Yeah, so this is the same as log base 10 of 5. And then the other one, do you remember what the other one is? ln, that's the natural log, is equal to log base e of 5. Okay, and so the thing to keep in mind is that ln is called the natural log, and it has all the same properties as if it was log base 10 or log base 2 or anything like that. It's just log base e. Okay, so just make sure you understand that. Okay, so I think that's everything I need to say about that kind of stuff. So let's just go ahead and flip over to page 317 here.
Man, you're a great teacher, Mr. Eversole.
That was a little over the top. You didn't have to quite go that far. Okay, so what we're trying to do here is just change it to the exponential form. So again, this is the big move. So it's called log base 3 of 81 equals 4. So the bases don't change. My colors here. Right, so then it's 3 to the exponent of 4 equals 81, and that's an easy thing to check, right? 3 to the 4th, you put it in your calculator, it becomes 81. Okay, so is there anything, do we need to do any more from 1 to 7 there? Okay. Oh. All right, so the next section says write the exponential equation in logarithmic form. That sounds pretty easy to me, Sophie. So, right, we got, I'm looking at number 12 here. 9 to the 3 halves equals 27. So what is that as a logarithm? Log base 9. Sorry, I'm having marker issues back here. What's going on here?
It's log base 27.
Log base 9 of 27, yeah, equals 3 halves. Is that okay? All right, seems easy enough.
It's like
Yeah, you guys got some E that you guys do?
And then that we do the L, we go from 9 to 27.
Okay, yeah, E's and L's, yeah, I don't know. Yeah, if it works, do it. I just say like, because if you think that, to me, the way I do it is, right, if you know that this is called log base 3, well, this base 3 is still, when you have an exponent, you call it the base and the exponent and stuff like that. So however you guys need to do it, just make sure you do it right. Okay? Now, if you look at the next two sections, 19 to 30 says evaluate without a calculator, and 31 to 40 says evaluate with a calculator. So, 31 to 40, just put it in your calculator because that's something that you have to do. These are going to be crazy decimal exponents, and nobody knows what, 5 raised to the pi is. Like, no one knows that. Or no one knows what 3 raised to the 2.7898. No one knows these things. So that's why you have calculators. They used to have things in the back of the book that you had to look up in charts. Okay, so do it on the calculator. Make sure you know how to do it. But we can do a couple of these. People had a couple questions on these before. So we'll start real easy. Log base 2 of 1/8. Okay, and so then what you're saying is what the heck is that? And so that seems like a good place to have a variable. And so then you can just say that. And so again, yeah, so 2 to the x equals 1/8. And now what do you do?
we did this one.
Yeah, how do you do it though?
No, you don't swear. You don't buy.
You just guess and check.
No, don't guess and check. No, don't guess and check.
Isn't that if the bases were the same, then the X would be equal?
Correct, yeah, correct. Yeah, so if the bases are the same, then because it's an equation, we would say the exponents have to be the same too. So then we need to make the bases the same, and I would suggest you always go from the bigger number down. So don't mess with 2, mess with the 1/8. So what can we do exponent-wise with the 1/8 to make it into a 2? Okay, so we can go to this. So 1 over 2 cubed, that's pretty good. But those bases are not the same yet.
2 to the negative third.
Okay, so yeah, you got to remember that one. So I'm going to write it out. This would be, God, that's awful. So there'd be 2 to the third to the negative first, right? And what you're doing is saying the line I just wrote is equivalent to the thing that's directly above it. So then your exponent rules say multiply there, so then 2 to the x equals 2 to the negative third. Okay, and so then x has to be negative 3 for both of these things to be equal. Is that okay? Would you like to do another one of those?
Yeah.
Okay, so pick anything from 19 to 30 except for number 20 there.
25.
Okay. Excuse me. Yeah, no one likes this one. You get a lot of questions on this one.
It's the one I'm stuck on, so that's why I
You're that far.
You're doing the homework?
am on 25.
What the heck?
We do homework in class. Like 1 through 17 just.
Isn't homework in classwork?
Yeah, that's why I get it.
So then you just don't do homework. You still don't do homework.
Sleeping class, I don't understand. If class isn't the time for sleeping, then home isn't the time for working. you got a point.
No, yeah, that makes no sense. Just because you pee in my toilet doesn't mean you can pee in my pool, right? Like, I mean, like, what are you even talking about?
Like, if you can't sleep
Well, I'm not allowed
at
to sleep
school.
at school, why should I have to do schoolwork?
You have to work at school, but you can't sleep.
Home is the only place you're allowed to sleep.
I don't think anyone's telling you that you have to do work. You just don't get a good grade if you don't do work. I mean, like, it doesn't make any sense.
That's nice. I like
It's just that they give me both of
Like-
their phones, and so now they're not distracted.
They took
I
someone took
have
it.
their phones right here. I've been taking them the past 2 weeks.
Hey, are we still?
Oh, no wonder they're doing better. You ought to charge them for their grade in some fashion.
She bullies us.
Yeah, but by the way, the answer's
Someone should.
Emily
All right. So what is this? What is this?
it's -2 because.
No, hold on. No. One thing at a time. What is it as, like, you change it to the other form, right?
It's 10x equals 0.01.
All right, so,
But it's 2 decimal places, and it's like, if we're in like chemistry and we're doing.
yeah, so, oh, good, yeah, right. Yeah, so scientific notation, right? Yeah, so that's a good way to do it. I'm gonna do it a little bit differently, but yeah, that's perfect. Yeah, you move it over a couple spots. What is 0.01 as a fraction? 1 over 100. And so now it's just like that one before. And so we could say, well, this is 10 to the x equals 100 to the negative first. And then 100 can be written as 10 squared.
I didn't know what I was going to do, so I asked him to do it.
Our brain is.
No, it's a good question.
Oh, now I see it.
Yeah, it makes sense.
Once he showed me how to do it, that's right. Or that, I didn't know how to do it. Thank you.
Was that okay?
Yeah.
All right.
This is exact.
No, this is good stuff.
It was weird at
All right,
first.
make sure you guys do 41 and 43. I'm not gonna do those, but those are kind of similar to those problems, that problem that we talked about at the end of the class. When I realized that you guys just, like, when you get a hard question, you just ignore it and don't ask me, and then go on with life. And sleep at home and work at school or whatever his problem is. I think he went back down to that kid up there. Okay, and so then 45, 47, 49 are just matching matching the figures, okay? So you got calculators, check them out. I told some other people this earlier. You guys got graphing calculators, use them to look at things. Type it in, look at it, and then that gives you information, okay? Don't be afraid to look at these things, that's the whole point. All right, any questions?